Are you spending long hours using techniques such as active recall, spaced repetition, but you're still not getting the grades that reflect the amount of energy and effort that you're putting in? As a very curious individual who loves to learn, is always trying to learn something new, I've done the research and I've helped fill in the gaps. So active recall, spaced repetition, definitely super important, but there's also some important things that we're missing to really complete this whole system. Today I'll be talking about the science of how we can really ensure that we maximize how much we retain, especially for long durations and if we want to apply it later on. And second of all, I'll explain this process that I created based on the evidence that I've been looking at. Hopefully it's very useful to some of you, so stick around if you are interested to learn more about that. So before we dive in with the system, let's start doing a little deep dive on the science and the why behind things. All right, so the information processing theory has three different modes. So we have sensory stimuli, which usually is any sensory information that we get from our surroundings, and that's inputted, usually just forgotten because our brains don't really think this is important information to keep for long term. Then in our working memory, we are able to take in around 7 items. Our working memory can be thought of as the RAMs of our computers. So that is where all the information is. If we want to actually conserve this, and if this is deemed important for our brains in the long-term storage, then of course we will move this information to the long-term storage. The process of moving working memory to long-term memory is going to be encoding. So that is going to be one of the main keywords of this whole process that we will be talking about a lot. So working memory to long-term encoding. And then once we take the information from our long-term memory, we're going to be using retrieval. So retrieval is usually what you have in mind when we think about studying. So again, active recall, spaced repetition, Feynman technique, that's really retrieval. But today in this video, I really want to focus on the encoding aspect of it all. So the second real science to learn about this goes with the working memory. So we have this cognitive theory load. Essentially, it talks about the strain or the discomfort that you feel when you have ideas or new information in the working memory and you want to pull it to the long-term storage. There are 3 types of cognitive load. So we have intraneous cognitive load, extraneous cognitive load, and germane cognitive load. Germane cognitive load is going to be the most important one. But let me discuss a little bit more about all of these. All right, so intrinsic cognitive load is essentially how hard this actual material is to grasp. So for example, if you're comparing a biology course compared to a mathematical course, it's a little bit harder to follow through a mathematical course if you were to zone out for a few seconds compared to a biology course. This does not mean that one course or one material is harder than the other. It just has a very different intrinsic cognitive load. So we really want to minimize this intrinsic cognitive load. Then we have extraneous cognitive load. So these are external factors that might affect the way that you retain this information. So some examples of this are basically the way that you're able to take the information. So maybe the lecturer or whoever is teaching you the material has a weird accent, or there's a language barrier, or you're not able to read the little fine print on the lectures because sometimes they're super duper small and you're just struggling there. You're like, I have my glasses, I just can't read that. Any way that affects the way that you're able to take in information is going to be part of the extraneous cognitive load. So as you probably guess, you really want to minimize the intrinsic and the extraneous cognitive load. The one that you do want to maximize though is going to be the germane cognitive load. So germane cognitive load is the way that you're able to connect information that you're learning right now to any previous information that you have learned. Making these connections is going to strengthen the neurons in our brain. So now that you're caught up on the cognitive load theory and the information processing theory, let's actually dive into the system, which is something I'm the most excited about. All right, so the system is going to have 3 different parts. We will have the priming part, the encoding part, and the retrieval part. So even though we do have 3 parts, I really want to focus on the encoding, which is what is going to be unique about this video. You probably heard all these techniques for the retrieval part, but if you are not putting information correctly inside our brains, how do we expect to actually retrieve it when we want it and not just have fragments of information that could potentially be useful in the situation, but we didn't really encode them right. So they're more detrimental than helpful at this point. Okay, so for the priming, there's 3 different things to have in mind. It's going to be the importance, the blueprint approach, and creating predictions. So let's start off with the first one. So whenever you're learning any new material, you first need to understand, how is this important? Not just important overall, generally, but why is it important to you? Because if it's not important, then what's the whole point of trying to take this new knowledge in? So once we know how it's important to you, then I like to think of this blueprint approach or the bird's eye view. So we're going to zoom out of the material that you are learning and try to find, like, what are the big ideas are going to be discussed. So if this is a class, usually just looking at the textbook, it already has everything broken down, so you don't really have to do much. If this is a real life application, you're trying to find, like, what are the biggest ideas of this. And the third thing for the priming is going to be to make a prediction. Why? If you really haven't learned anything about this, I want you to make a prediction, because if you're going to make a prediction, you are now invested in the new material that you will be learning. If you're invested, you're going to want to stick around and finish this lecture, finish this new knowledge that you're trying to learn. So I want you to be interested and invested. That's the whole idea of this priming. So now that we got through the priming, let's move on to the encoding, which is essentially the most important, the meat of the system. So for the encoding portion of the process, I want you to focus on cognitive load, 3 questions that you're going to be asking yourself, and I'll discuss this a little bit more, and Bloom's taxonomy. Okay, so cognitive load. So we talked about that. That's going to be the cognitive discomfort of acquiring new knowledge in the working memory and transferring that to the long-term memory. So now that you understand the science behind the cognitive load theory, we want to really maximize this. We want to find the optimal level where we are going to be lowering the intrinsic extraneous cognitive load and maximizing the germane cognitive load. So you're probably asking, like, how the hell am I supposed to, like, maximize it? Like, of course I know that I need to maximize or increase the germane cognitive load, but how do I do that? That is why I'll give you 3 different questions to ask yourself in order to maximize that germane cognitive load. 3 questions you should be asking yourself in order to increase germane cognitive load are: first, how is this information connected to other information that I have learned previously? Always making sure that you're doing those connections. Second of all, how is information unique, different now? Because we don't just want to pile everything into one, like, system or one category. We want to make sure that's still unique. And third of all, why does it matter for me? Why is this information that I'm trying to, like, put inside my mind important for me in the long term? Because if it's not important, your brain will not make sure that it stays in the long term. It's just going to go, forget. So you need to figure out your answer to those 3 questions. Another way to increase our germane cognitive load is to use Bloom's taxonomy. So Bloom's taxonomy is going to be this hierarchy of different ideas that we can look at. So it's the way that we are thinking critically about a different idea. So we have different tiers, and we want to aim to be at the top 2 tiers, which is going to be evaluate and create. So if we are evaluating, going to receive that until the end of the entire semester or the end of the quarter. So that is not helpful for you if you're learning something in the school settings. With that being said, I am going to need you to rely on intrinsic motivators. So what I mean by intrinsic motivators, I want you to be fueled by curiosity or just intrigued. If you are curious about really understanding why the heck whatever you're learning happens, you're most likely to stay focused and engaged. And again, remember, if you're focused and engaged and motivated, you're going to be releasing these neurotransmitters, which are going to help you retain information. And the last little tip that I'll give you for this whole system, if you take one thing from this video, I really want you to not cram. That is the worst thing you can do. You've probably heard it like a million times, but I need you to understand that it's way better to get a good night's sleep than to cram. Whenever we're sleeping, we're going to have an instant replay of the neurons that were activated in the same patterns that were activated. In other words, whatever you learn that day is going to be replayed in your brain when you're having some deep quality sleep. So please do not miss that. So to summarize, we learned the science of how to maximize and effectively learn something in a shorter amount of time using cognitive load theory and information processing theory. And then we talked about the process in detail, which incorporates priming, making sure that you're intrigued and motivated to learn something, encoding using cognitive load theory and Bloom's taxonomy, making sure you apply those high-level cognitive questions and asking yourself those 3 important questions. How is it connected to other things? How is it unique? And how is it going to matter to you? And once you ask yourself those 3 questions, making sure that you're in the right mindset so you are focused and engaged, and you can make sure that you're focused and engaged and motivated by eliminating the middle ground and making sure you rely on intrinsic motivators. And then last of all, making sure that you apply the right retrieval practices for whatever you are learning. So if you have a class that's more geared towards application based, making sure that you take the time to create questions and have study material such as past tense that are in the same format. So I don't want you to be creating Notion questions or questions on Anki, asking very simple things like, what is a mitochondria, if you're going to be asked to apply this knowledge. So making sure you have the right level of information retrieval for whatever you're going to be tested on. And if you're using this information to just learn something, making sure that the way that you will apply this knowledge in the future is the same way that you're retrieving and encoding is going to be super duper important. So hopefully this system is helpful, and also be attaching the written steps of this system and a worksheet on how to apply this in the description below. Hopefully this is going to be helpful to you whenever you're trying to learn something as efficiently as possible. Thank you for watching, and I really hope this was helpful to you at all. All right, thank you. Bye.